It shouldn't take the entire class period. Yes, dear?
Just so I can make sure I'm not feeling stupid. You mentioned this robot college.
Yes.
Okay.
Good question. You have a point. Yes, dear?
Are we eventually going to do division with these, or?
Let me finish my rant, and then, you can have a point for that, because that's a good question. So the quiz tomorrow should be pretty easy. It should not take the whole class period. We're still going to do a math workshop, and you're still going to have time to work on this giant list of stuff. Because if you notice, after I do notes today, there's a new workbook assignment. So when Xavier gets done with the quiz tomorrow, he can work back on his workbooks. He can do one of the things that he's missing. He needs to get his life caught up, because we're moving on to new and better things. Okay. We are going to do page 7 of our note packet today. Page 7 is not going to be on the quiz tomorrow. So what we talk about today is not on the quiz tomorrow. What we've done so far is matrix basics. We're finally going to get to intermediate with matrices. Instead of the easy part, we're doing the intermediate part. And you're going to be like, but Miss Compton, you're just mostly showing us the calculator, so that makes it easy, which it does. So, sorry. Out here, class be easy sometimes. So let me say that again for those who are listening. What we do today is not on the quiz tomorrow. No, not on the quiz.
No way.
Eventually, however, there will be a matrix test, and it will be on that. That should be one day next week. One day, Tuesday or Wednesday. We don't have that much left to do. There are tons of things left we could do with matrices, but Albert's too trick. We're almost to bidding matrices to do. I'm needing help with my math workshops. God, I want to do 8 factoring problems today. Lots of points can be given away, and I have one group that's been rocking it out on points. I'm assuming because Dre has been answering a lot of math workshops because they got really high this past week. I normally 2 and 3 get pretty high, and 5, but sometimes depends.
We get another one.
But 4 was on it last week. Let me tell you, points wise. Okay, number 1. Yes, dear. Okay. Yep, and you get a point for that, ma'am. You'd be left with 11x squared, y to the 3rd, minus 7, y to the 4th, plus 9, x to the 3rd. That's perfect, and you can have a point for that. Yes, dear.
Number 2, negative x plus a, negative x plus b.
You're going to be mad at me, Brady. You want to skip 2 for now. What were you using to get those answers? Can you tell me that, and I'll go ahead and give you a point? What's the term used when there are 4 of them? When you did this? Grouping. You get a point. Okay, we're going to come back to number 2 because it is actually a hard one today. We'll discuss it in a minute. Let's go to number 3. Yes, dear. Let's go Jessica. That way another group can get a point.
Alright, so you get 6 minus 1 will equal 5, and then 6 times negative 1 will equal 6. So you get c plus 6 and then c minus 1.
Perfect. Okay, like she said, 6 minus 1 is 5. Negative 1 plus times 6 is negative 6. So it's c minus 1 and c plus 6. Perfect. Beautiful. You can have a point for that. And it was well explained. You can have another point. You have 2 points for that. That was really well explained. Landon. You can have 2 points if you'll tell me what you were using. Yeah, so they're called what then? Like the number 16 is a I knew you knew the square root of it was 4, but it's called a perfect. Yeah, and you can have your 2. Okay, so there is another perfect square problem. I want to go to it next. What is the other perfect square problem?
Number 8.
And you can have a point for that. What is the answer on number 8? I know 169 is 13. I just need to know what square gives you 441. Yes, dear.
21.
Yep. You get a point. So 21 minus 13h and 21 plus 13h. Now to number 7. Number 7 and number 3 look oh so similar. They've got 1s, 5s, and 6s. But with number 7, it's a negative 5 and a positive 6. So it's just a sign difference. Sadly, changes our factors. Yes, Drea? That is correct. But I just think that's crazy that just a little tiny sign difference. I mean, like, look at these two problems. They look so similar, but the sign differences changes the factors entirely. So you really have to pay attention to your signs. You can have a point for that, ma'am. Okay, what about number 6? Yes, Travis. Plus 2. Okay, so Travis did grouping. With his first group, he pulled out an n squared. He was left with an n plus 2. In his second group, he pulled out a negative 9. He was left with an n plus 2. He was happy. Why was he happy? Because they matched. So then he said the answer is n squared minus 9 and n plus 2. And I'm going to give him his point. However, that is not the final answer. And Landon and Brady get a point. N squared minus 9. Isn't 9 a perfect square? So if we broke 9 down, n plus 3, n minus 3. Anytime I see a perfect square like 9, I start wondering, hey, can I break it down further? And this time we could. Okay, number 6 went well, and number 5 is where we're going to crash and burn. But maybe y'all are smarter than me today, because I only know to do one thing. Yes, dear. Yeah, so I took out an x, but the issue is after that. So I got to take out an x, so it's x to the 4th plus 7 x to the 3rd, y to the 3rd, minus 8 y to the 4th, plus 14y. I got that. My issue is after that. Yeah, when I tried grouping, I didn't get the same. I failed. So I'll show you what I tried. That should be an x. Yeah. Okay, so I tried grouping, and so I pulled out an x to the 3rd, and I was left with an x plus 7 y to the 3rd. And then in my other group, I pulled out a negative 2y, and I was left with 4 y to the 3rd plus 7. And so, yeah, they both have 7s, they both have y to the 3rds, but they don't match. All you can do is factor out the x, or so I think. I'm like 90% sure I'm done, but I've got this 10% bit of doubt in me. So here is my suggestion, although be prepared to fail if you do try it. I am willing to give 3 points on the next test next week if you can make this one factor further. My suggestion would be maybe to rearrange the terms. Like maybe if they were in a different order, we would pull out different things and life would work. I can't make it work today, but I'm telling you, sometimes you're hot, sometimes you're not. Okay, we did skip number 2. We need to go back to it. I can make number 2 work. However, as it is, it won't go. What's wrong with it as it is? Yes, ma'am. Because is there anything we can pull out of this first term right now? No. So we have to rearrange the problem. No one said we couldn't. No one said we couldn't put it in a different order. So let's leave x squared where he is. I'm going to put bx with x. And then I'm going to do ax and plus ab. I decided to put them in order with like the x squared guy, the pieces with x's, and then the piece with only a's and b's. I thought maybe that might work, and it is going to. You might have to rearrange it another way another day. It just depends. But you're allowed to rearrange the problem. If we do grouping now, what can I factor out of that first group? If I factor out an x, I'm left with an x minus b. Brady, our answers are going to have different signs, but it's okay. If I factor out a negative a, what am I left with in the other group? And I'm happy because they match, so my final answer is x minus a, x minus b. Dre, you can have a point for that. And Brady, I should give you another point for earlier because you had the right answer. Well, yours has different signs than mine, but it's still correct. Okay, are there any questions about these math workshops? I know we normally don't when we test, but we are going to go over 9 through 12 tomorrow. So if you're trying to get some points, have 9 through 12 done on this page. Not the other page, this page. Okay, as for our notes, page 7. Yes, dear. Page 7. We're dealing with something new today called a determinant. So, let me give a little bit of a background. Okay, so let me start by saying we're going to do the bare min with determinants. It's really going to be depressing how little we do. In fact, after we do 2x2s, for 3x3s, I'm just going to teach you how to do it in the calculator. I can show you how to do it by hand. It's no big deal, but it requires patience. The way systems with 3 equations, 3 unknowns require patience, it requires a little patience. And since we really need determinants to get to this next part, we don't demand that you know how to do 3x3 by hand in Algebra 2 trick. We don't. We ought to, but we don't. Okay, so Jessica asked a question at the beginning of class. She said, hey, we've added, subtracted, and multiplied with matrices. How come we haven't divided? You actually can't divide with matrices. It won't work. So we end up having to do something called an inverse instead. And in order to use inverses, which is what we're going to do at the end of this week, in order for that to even work, we have to see if our matrix has a determinant. So the whole point of today seems silly, but we're just going to get a number, like 52, negative 49. And all that matters is we don't get 0. If we get 0, we're going to be done. Like you and me and matrices, we've done all we can do. But as long as the determinant's not 0, we can make more math happen. Okay, so I should add that we're specifically going to work with 2x2s, 3x3s, and if we wanted to, 4x4s, 5x5s, etc. What kind of matrix is that? It's called a square matrix. Ready to get a point? Okay, so we're only going to be talking about, from this point forward, square matrices. Has to be square. So same rows and same amount of rows and columns. Okay, and then the next thing to notice about determinants is that we're no longer writing with the brackets like we were. Instead, now we have bars. What do these bars remind you of? She can have a point. They remind you of absolute value bars, which is concerning because with absolute value bars, you're not allowed to have what kind of answers? No, and every group can have a point. You're not allowed to have negative answers. That's the difference with a determinant and absolute value, is it's okay to have negative answers. I'm going to put negs because I'm lazy. Okay to have negs or okay to have negative answers. Again, as long as we don't get 0, we're happy. If Drea gets negative 42, that's great. We only don't want to see the number 0. It's okay to have negatives. So I know that looks like absolute value bars, but anytime you see a determinant like that, it's okay to have a negative answer. Okay, if you're really interested in determinants, because I'm telling you there's this whole world of matrices we're not even going to get into in Algebra 2 Trig. If you're really interested, I'm going to post a nice link on Google Classroom you're more than welcome to look into. For me, I'm going to keep it simple. If you like letters, I'm going to explain it with letters, and then we'll just work some problems. So if we had a matrix and its entries were A, B, C, and D, so it's a 2x2, if we were going to calculate its determinant, we're actually going to use the diagonals, the product of the diagonals. We're going to do the product of the pink diagonal, so AD, minus the product of the green diagonal, so BC. So it's the weirdest thing ever, but we seriously multiply the diagonal numbers and then subtract the other diagonal number. So strange. But that's how you get the determinant. Okay, so for our first problem, I'm doing 6 times 7, which is 42, minus 5 times negative 2, well, that's negative 10. So it ends up being 42 plus 10, which is 52. Then with our next problem, still using diagonals. Negative 6 times negative 1, you get positive 6, minus negative 4 and negative 3 is positive 12, so my answer is negative 6. And then this last one I need a little help with because I'm not a calculator brain. 8.6 times 5, get a point, minus 14 times 5 is 7. So 43 for the pink diagonal, minus the green diagonal is 7. 43 minus 7 is 36. And literally that's it. So I'm needing answers on 4 and 5. Your group can get a point if you get them first.
Quick question.
Yes, dear.
Okay, when you, okay, I'm sorry,
Here.
when you end up with, like, if you end up with a negative answer
That's okay.
for the, not, I mean, for
The second one, it ends up being a positive because minus a negative.
yeah,
Yes.
that's what I was about to-
Yes, like number 1. So you have to be very particular about signs. So what I'm going to show you in just a minute, after we go over 4 and 5, I'm going to show you how to put it in the calculator. So I think it's way faster to do by hand. If you're prone to sign errors, which I know I am, it wouldn't hurt to check with a calculator at least. Okay, Naya, you had your hand up for one. Which one, ma'am? And she can have a point. It ends up being negative 42 minus 72, which is negative 114, and she got her point. And then I'm going to let her have it. Do you mind? Okay, go ahead, table 5.
Okay, what do you do, like 420 minus 276?
Absolutely. Absolutely, and you get a point for that. So I think, because I don't mind doing this, it's just multiplying 2 numbers and subtracting, like it's really not a big deal. So I think personally that it's easier to do a 2 by 2 by hand than to bother to put it in my calculator. But we're going to go over now how to do a 2 by 2 in your calculator because that's all we're going to do on 3 by 3. So might as well know how to do them all because they all work the same way. So I'm going to type number 5, no, let's do 4. I'm going to type number 4 into my calculator and make sure that we get the same number. Okay, so we're still going to press second matrix. Oh my goodness, my calculator's been used a lot today. Let me clear out my entries first. Second memory, clear entry, memory management, matrices, go away. Okay, so I still want to enter in a matrix. So I'm going to go over to edit. I'm going to type it in A. I need a 2 by 2. My entries are 14, 8 for my first row. Negative 9, negative 3 for my second row. Is there anyone who doesn't know how to get here? Okay, so we're done with this screen because we've typed it in. The best way to get out of it is to second and then quit. Second quit gets you out. Second quit. Okay, but I'm wanting to do math with matrices, so I press second matrix again. I'm wanting to do some math, so I scrolled over to math, and lo and behold, I already see what we need to do on the screen. DT, determinant, that makes commons, we got that. Yeah, Miss Compton. So I press enter because I want to take the determinant. The only hard part is remembering which matrix you typed it in as. I typed it in as A, so I want the determinant of A. I press enter. My calculator gave me the same number that Naya gave me. Okay, so I did second matrix. I scrolled over to math. I pressed determinant. I had to press second matrix again and then enter for A. So if I had wanted to do second matrix determinant, if I had wanted to do B, I would have second matrix and then scroll down to B and press enter for B. But I don't have anything typed in, so it's going to freak out when I do it. Yep. So you have to press second matrix a couple times, I'm not going to lie. So that's why I think a 2x2 would probably be easier by hand. But a 3x3 is going to be a heck of a lot easier with the calculator. I could explain to you how to, but you really don't want me to today. You want to know the fast and easy way, trust me. So I'm going to go to second matrix, and I'm going to edit matrix B. I'm going to turn it into that 3x3 on number 6 right after I answer Eighth Grace's problem. Yes, ma'am?
I have the answer.
Oh, okay, perfect. Hold on. So I'm wanting on number 6, it's a 3x3. So I got to type in 3, -2, -2 for my first row. 3, -2, -2. 0, 4, 1 for my next row. 0, 4, 1. And then -1, 5, -3 for my last row. So I've got it completely typed in. Then I quit. I press second matrix. I go over to math. I'm wanting to take the determinant. I press second matrix again. I'm specifically wanting, oh, I typed in an A. Whoops. And I got -57. Is that what you got, Abby Grace? Does anyone not understand how I got -57 on number 6? Yes, ma'am. So, are you good with typing in the matrix?
I did it, but I did it at C, and when I put C, I got 0.
Okay, come show me yours. Come show me yours. I can look on your calculator and see. Okay, I'm needing 7 and 8. I'm only doing number 6, so I need 7 and 8. I know Abby Grace has 8, so tell me 7, ma'am.
I have -62.
That is correct, and you can get a point. And then Abby Grace, what's 8? 50. That's not what I got. You typed it in the C. Second matrix, edit. 3. You didn't type it in. You put it all as zeros. You have to edit it, and put, you know what I'm saying? So my second matrix, my 3x3, if you go clear, second matrix, edit. My 3x3 has all the entries from my paper.
Oh, okay.
Okay. Okay, cool.
I hit the wrong letter.
Yes. Is that what you got?
Yeah, I put the wrong letter.
You can both have a point. Okay, so Abby Grace and I just learned a valuable lesson. She's very fast and very good at her calculator. If you're not super careful and you don't check it twice, more than likely Abby Grace is going to write down the wrong number, and then the whole thing's SOL.
You said Abby Grace on the point.
Yeah, she can. Okay, is there anyone confused about how to do this? Again, with a 3x3, that's all I need you to do is calculator button it. I understand that there are people in here who want to know more complicated stuff. I will gladly show you one-on-one, but you do not want me to overwhelm the majority because it would be a bit much. And again, determinants are needed for something else. So as long as we know how to calculate the determinant, we really need it for this next part. So the next part's a little more important. Okay, you have a workbook assignment I need to work on. If I call your name, I have something of yours or I'm missing something, and then I know some people want to show me stuff.